if you imagine you have small micron-sized dust particles levitating in a discharge, in a gas discharge, which is an ionizing environment. So whatever you put there, it will get charged. It will acquire electric charges. And as we know, charged particles do interact with each other. So at the end, if we put in many particles, thousands, 10,000s of particles, we get a large ensemble of strongly interacting particles, a many particle system, which is a very challenging system to describe theoretically. I mean, classical mechanics can describe the motion of one or two particles, but already a three-particle system is not solvable analytically in the sense of predictive power. But for a many-particle system, only statistical methods are available. But on the other hand, of course, all of us know what many-particle systems are because all matter is made of lots of atoms, which do interact with each other. But of course, the problem with the atomic scale is that we cannot resolve, we cannot see individual atoms, and we cannot follow individual atoms in time, how they move, how they interact with each other, because they are just too small and just too fast to visualize them. On the other hand, dusty plasmas, we have these dust particles, which of course they are micron size, but it's already large enough to be seen with video microscopy. So one can illuminate these particles with the light source, typically a laser, and then these will scatter enough light that one can capture it by normal video cameras. And also the time scale of the motion of these particles is in the range of human time scales. So they oscillate, they vibrate something like 10 or 20 times a second, which can be resolved by not very fancy normal cameras. So we use these systems actually to model what's happening in atomic systems. We cannot resolve the atomic motion, but we can resolve the dust particle motion. And if we can prepare a system, for example, in a crystalline phase or in a liquid phase, we can apply different forces on it. We can manipulate the system like we do with atomic matter. If we take a piece of metal and do some experiments with tension and torsion and plastic deformation, then this is something we can do with on these systems. But again, compared to the atomic matter, here we see what's happening on the particle level, individual particle level.